All right, doors closed, so ready to go. First of all, thank you everyone for sticking around for the last panel of the day. But you know what the old saying goes, you save the best for last. And in my case, I'm the bookends. I started it off and I'm ending it off. But this is we had a nice panel just before this regarding utility thermal energy networks. And this one is really about, it's titled Opportunity Presented by Municipal and Private Thermal Energy Networks. And we have a really wonderful panel here, and I'll let them introduce themselves and their companies. But they're active in this space, designing, engineering, and building these thermal energy networks, both for municipalities and for private entities. So we have, again, we'll have you introduce yourself, but John Tesh, CHA, we'll talk more about the municipal side, because they have a couple of municipalities that they're designing projects for. Sue Dougherty actually is going to start it off talking from a NYSERDA perspective, what we've done, talking about our Pond 4614 and some of the projects there. Dan Sergison would talk about, from Salas O'Brien, we'll talk about the private sector. They've done some of the largest projects in the country. And then Tim Banach from Endurant, which will talk about both public and private, but more from the financing aspect of it, because we need to get these projects financed. So I'm going to step aside and have Sue come up first to talk about this from a NYSERDA perspective.
Thanks, Donovan. Like Donovan said, my name is Sue Dougherty. I'm on the Community Thermal Networks team at NYSERDA. No relation to Ryan Dougherty, but it is nice that we've been deploying a fleet of Doughertys to address geothermal at both the national and state level. So we're recruiting more. Should you be a Dougherty, please join the team. So like Donovan said, I'm going to talk a little bit about what we're doing at NYSERDA and a program that we had open for a few years called Pond 4614, Program Opportunity Notice 4614, also known as the Community Heat Pump Systems Program. We have gravitated towards calling these systems thermal energy networks, but you may also know them as district energy systems. I feel like we're in good company here. So I probably don't have to run through all of the potential names for these systems, but we're talking about the same thing when we're referring to these network systems that are connecting multiple buildings together to heat, cool, and provide hot water. Prior to this session, you may have sat in on the session about the utility pilots, and like Donovan said, we're going to be focusing more on some of the campus or privately owned and community-based projects that we explored through the program that we were operating through our Community Thermal Network team. So Pond 4614 launched in early 2021. It was open for 10 rounds, and we had our last round last fall. So through and if you've joined any of the GEO conferences over the past few years, you've probably heard us talk about this program already. The numbers have grown over time. We had a very high response rate when we first opened the program. There was pent-up demand, a lot of interest in exploring these types of project opportunities, and we continued to sustain that interest throughout the duration of the program. So we're able to surface over 50 different project sites throughout the state to do feasibility, design, and construction projects. And some of these projects have actually advanced through the different stages. We're still in the contracting phase with a lot of these, so I won't name any of them specifically, but you can go on our Community Heat Pump Systems website at NYSERDA and get more information about each one of these projects. There's fact sheets that talk about where the projects are located, the wonderful project developers who are helping to do these studies and designs, and some more detailed information about each one of these projects. And this was really a pilot program, and we woke a sleeping giant. Like I mentioned before, there was a lot of pent-up demand and interest. And so we've surfaced a lot of opportunities. Some of those have actually evolved into the UTEM pilots that were discussed in the session prior to this. And we're continuing to identify new project opportunities as well. So while Pond 4614 is closed, if there are project sites or project developers that want to explore whether or not a thermal energy network is a good fit for a particular location, they can come through our FlexTech program at NYSERDA. I think it's Pond 4192, that you can come talk to me afterwards. I can help connect you with the right team members at NYSERDA, and we can get an application in to do a 50% cost share of a feasibility study for a thermal energy network. And while we are very excited about thermal energy networks, it's really an opportunity to determine if it's the right fit for a particular project location. So don't be intimidated and think that just because you have a great project site and maybe it's not the best place for a network system, we really just want to identify any opportunity to sensibly electrify buildings throughout the state. So bring us your project opportunities. And so looking at this map here, you can see that the opportunities are everywhere. We have a pretty even split between projects that we are studying both upstate and downstate, even one all the way up in Saranac Lake, and one of the folks on the panel here will talk a bit about the rural project opportunities that have been explored through Pond 4614. They're all types of projects too. So we have projects that are looking at college campuses, both SUNY campuses and private college campuses, hospitals, multifamily complexes, mixed use and commercial opportunities. So it's really quite a range of different building end uses and size. So you have projects that range all the way from just tens of thousands of square feet of conditioned space that are being explored all the way up to 10 million square feet of conditioned space that's being explored through these various different projects. And I will, in keeping with the tradition of today's conference, I will say that one of the most prominent thermal resources is geothermal or ground source heat pumps. So ground source heat pumps are the technology that's being explored most of these projects, but we really are looking at a lot of different thermal resources. So wastewater heat recovery, waste heat recovery, surface water. We have projects down in the city that already have permits that allow them to draw water from the rivers or from the ocean. So they're taking advantage of that opportunity to use the water that's abundant as a thermal resource for heating and cooling. Also giving some love to air source too, because they're in the right place and application. Air source is a good way to complement or enhance these multi-source systems. And there's really a range of business models too that are being looked at through these different projects. So I mentioned college campuses. There's also public-private partnerships that are evolving through these different community-type projects that my panelists will touch on a little bit during their discussions, and looking at some cooperatives. So there's already existing district systems or district steam systems that some communities have in place, and those cooperative models are being explored to try to transition those projects to lower temperature thermal systems that can accommodate geothermal. So in addition to doing studies and designs and construction projects, we're trying to help these projects navigate the what could be complex permitting processes in New York State and the ever-evolving codes and standards that will help make sure that these projects are developed in a uniform way. And going forward, Donovan mentioned in his opening remarks earlier today that it is our intent to continue to support these projects through the pipeline. The majority of the projects right now are at the feasibility phase. There's a lot of very promising projects that we're working with that have both technical and economic feasibility, and we want to help those projects advance to design. So our focus going forward would be to help advance those promising projects to the design phase. We want to focus on very replicable projects. Projects that significantly reduce energy and greenhouse gas emissions and take advantage of waste heat recovery and thermal storage. And that's what we intend to do going forward. So I will turn the mic over to John, who will be up next from CHA to talk about some of the projects, exciting projects that they are helping to develop.
So good afternoon. Thank you for that introduction, Sue. My name is John Tesh. I work for CHA Consulting. I don't have any slides, but I am going to talk your ear off about the two projects that I've been asked to kind of discuss during this panel. The town of Saranac Lake, town of Saranac Lake, that is a very exciting project in the sense that one of the challenges in developing any sort of thermal energy network or municipality system is that we have to have the means of, billing the customers. We have to actually man the ship. And so one of the thresholds that we need to identify is, do these towns, what kind of municipal systems are already in place? Do we have combined sewer outfalls, stormwater, gas, power, water, et cetera. So we try and find opportunities that when the town is normally doing its maintenance or just improvements and they're cutting open roads and they're doing these capital projects, that's when we want to start dropping pipe in the ground, right? We want to take advantage of strategic opportunities to build these large districts as they become available, because we don't really operate in a vacuum where I have a clean slate. I can just go ahead and start just drilling holes, laying pipe, and making my customer connections. So once we've established that we need to have, an actual office that's going to, bill the customers, maintain the system, man it, we then need to develop our relationship with the stakeholders. And that's probably one of the largest lifts because, not every stakeholder is the same. Some people require more heat, some people require more cooling, some people have massive domestic hot water loads. And so, you have to play this balance point with identifying, who has what and who needs it, and we have to come in sort of, we have to come into agreement on how we're going to share this energy, and that's something that really hasn't been, ironed out yet. Like, who gets the best rate? Is it the data center, or is it, is it the LMI, institutions who need that heat and hot water and air conditioning? So, lately we've just been developing something that's called a thermal rate. We try and keep that around 12 cents per square foot for larger commercial entities, and we drop it for residential. And that enables us to kind of really see where people are going to be paying for their power, right? And who needs to pay into the system and who gets to really benefit from it. So for Saranac Lake, we're going to basically create a structure, and we're going to place it in the Saranac River that makes a bend around the town. At that location, there's already a hydroelectric dam. There's also hydraulic pumps, meaning that the river water is driving these pumps, which provide water. We're hoping to reconfigure these three buildings such that the electricity by the hydropower dam is going to drive the engine. That river is going to drive the pumps, and our district pumps will be basically free pumping from the river. We have a large LMI tower located in Saranac Lake that is almost kind of like I wouldn't say a miniature city, but maybe, it has a lot of self-contained entities within it. It's not just an apartment building. So they are definitely a stakeholder, and they're the ones looking for, looking for this U10. We've got a very nice hotel downtown that's GEO ready. Currently, they've installed water source Daikin VRF units, so they're excited about the opportunity of getting a district GEO loop developed. Town Hall, town of Harrietstown, which is where Saranac is located, they're all on board. So, speaking as someone who has been working on these feasibility projects and doing these heat pump studies, the easiest part is doing the engineering. The hard part is the social interaction and coordination required to get all these moving pieces kind of heading in the right direction so that we can start to build these systems. Moving on to the town of Woodstock, which is another project that I've been involved with, and we should be submitting, the final feasibility report to NYSERDA. The town of Woodstock is a unique situation in the sense that, It's very famous for its name, of course, but it's also very, you know, rural, right? It's very bucolic. And so, you know, Central Hudson Gas and Electric, they've got power out there, but they've got no natural gas line. And so coming from the Hudson Valley, the last 20 years living there, you know, I kind of can detect, like, in a town of Woodstock, you know, there's like 6 energy providers, and they're clogging up the streets. You have all these bottle gas, you know, LP gas tanks, buried fuel tanks. And Woodstock's not a really big town, especially when people want to walk in the middle of it. So I'm lamenting over this, as we have to also take a look at maybe a holistic look at what we're trying to do. And it's not just the energy efficiency measures that I'm trying to take on, but I'm also trying to limit the amount of traffic and you know, highway fuel, all these other sources of energy being spent to trying to deliver energy to a very rural town like the town of Woodstock. So in regards to Woodstock, they already have 2 existing geothermal systems for the municipality, and they were installed in 2012. They've been running pretty good, and you know, the town of Woodstock would like to see if that we could just, you know, just make the whole town one large U10. They have the stakeholders on the municipality side, they're all on board, but right now we haven't been able to, you know, again, talk to the community and get buy-in. You know, we've got the Sunflower Market. They have a lot of refrigeration equipment, so they're looking forward to coming onto the U10 because they will be paying less energy to, you know, provide their refrigeration. We're looking to the Sunflower Market as what I call like the pump primer. I know that they're always going to be in cooling, so I want their heat. Town of Woodstock is a very diverse, very diverse set of construction spanning over 200 years. So it's no surprise to me that you know, the hardware store has 2 steam boilers, a rooftop package unit, and a couple of mini splits happening. It's true. And, you know, so the approach, as CHA explained in the town of Woodstock, we've got a very good model. You know, we've got 600 holes that are approximately about 1,300 tons of capacity. The model has allowed us to not put any glycol in the ground because the fluid is staying warm enough. And the hopes or the attempt is that as we start to pick up clients and ratepayers, if you will, and connect them on this district, the savings, the overall savings in energy will allow them to start to improve the envelopes of their buildings. The homeowners are going to be empowered to, you know, put on insulation and, you know, better performing house, as well as the municipality buildings, so that we will have extra capacity to then, you know, spread the district and touch maybe the school, which is not part of the town of Woodstock School District, but it's right there. And, you know, again, we want to give good, clean heat and energy to the people who need it most. The stakeholders of the town of Woodstock, because of just the history of the town, it's a very eco-sensitive area as well. So that has been, you know, it's proved to be trying how you navigate people's concerns. You know, some people are very passionate about, you know, the nature, and they want to be assured that you're not going to disturb it. Other people, you know, other stakeholders are very concerned about the noise, and so they're making sure that we're going to throw a lot of money at, you know, quieting the drilling process during the winter. I won't say it's been proving frustrating, but again, I've learned that, you know, diversity is a very key ingredient that we need for U10s. The more diverse, the better these systems can work. And also that we really need to listen to who our client is and our ratepayer, because their concerns are real, and we just need to, you know, we need to be there to help them make this transition, you know, no pun intended, to a new energy source, and they just need to be comfortable that it's going to work. So, you know, it's very exciting, you know, what we're doing now. I'm really happy in the upcoming years to start to see some publications of the projects that we've been working on when we finally turn the switch on. And, you know, I'm very excited about the opportunity that, you know, geothermal heat pumps, they're going to get a good rep this time around, and we're going to be installing them for the next 20 years. So thank you very much.
Thank you, Donovan and Sue. Thanks to NY-GEO, and thanks to all of you for sticking around for the last session. not catching the 4:30 Amtrak like a couple of my friends. So my name's Dan Sergison. I'm an engineer for Salas O'Brien, working mostly on decarbonization projects in New York, New Jersey, Connecticut area. I live and work in New York. I have most of my life. I live downstate. Right now I currently live in Brooklyn, so I'm pretty close to a lot of the action happening downstate. And I've been working in the industry for about 10 years now. And I'm going to go over 3 thermal energy network projects at various levels of implementation. One that's basically, it's on the screen already, but town of Haverstraw, it's in the concept phase, and then I'll talk about a couple others. One that's about to go to construction, and another that's already been completed. And I do feel that, you know, the more shovel-ready projects there are, even if we're just up here talking about concepts, it does seem to me like the workforce is ready to go as long as we continue to talk about them. So I know there's a lot of concerns about, are there people that actually do the work? In my opinion, there are, as long as, you know, we keep NY-GEO and groups like this, you know, alive to talk about it. So town of Haverstraw. This is about 2 hours south with the west side of the Hudson River. We are currently working with the town of Haverstraw, a private developer, and Orange and Rockland Utilities. We're developing 2 separate loops. It's kind of hard to see on the screen probably from where you're sitting, but we have a west, on the left side we have a west loop we're developing, and then on the right side of the screen an eastern loop right along the Hudson River. You can kind of see the green piping that connects all the off-takers and all the energy sources. So on the right side of the screen, the east loop, we have a proposed development scheduled to start construction soon. It's actually called the Haverstraw Chair Factory. It used to be a chair factory. It no longer is. I believe the developers are naming it the Chair Factory. When they rebuild it, it won't be producing chairs, but it will be home to 450 units, including affordable housing, middle income, and market rate units. So they're going to be a big off-taker for the Eastern Loop. And you know, I guess if you follow that very faint green loop from there, there's also a library, the town of Haverstraw Library. They're going to be an off-taker as well. And a couple of residential homes, multifamily developments that exist already, commercial buildings, a post office, and a couple of churches. So they're all going to be connected with ambient temperature loop, and have ground source heat pumps within each of them, or at least that's the plan right now. And then the energy sources for that loop are going to be vertical boreholes and possible river source heat exchange. And then on the left side, the western loop will be composed of a few of the town of Haverstraw's municipal buildings. City Hall, they have a couple office buildings. There's an elementary school there with administrative buildings, support buildings, a good load diversity there. We have additional community spaces, residential homes, multifamily units, additional commercial buildings for the western loop. And the 3 energy sources for the left side of the screen are going to be vertical boreholes as well. We're looking at sewage heat exchange, a shark system, and we're also looking at just general heat recovery on that side. And then further, we are looking at connecting both the east and west loops with this purple loop. We're waiting to learn more about load diversity before we could really commit to that. But we already have some businesses and residences along that purple line that are very interested in getting off gas. And overall, we're anticipating about 500 boreholes across this entire site to about 500 feet preliminarily. And I will move on to the next project. You may have heard about this one before. This is the Children's Village. This is down in Dobbs Ferry, so it's Westchester County, just north of the city. This was, as Sue and Donovan talked about, a PON 4614. study, a community heat pump pilot program study a few years ago. So Salas O'Brien had done the whole study. It was well received by the client and by NYSERDA, so we did move to category B to do the full design of this system. So it is fully designed. And the site itself, as you can see, there's, I believe it's 180 acres. This site has been in existence, functioning as it does today since about 1653, quite old. There's about 49 buildings and 370,000 square feet of interior space. Many of these buildings are super old. Some of them are over 100 years old. They're in desperate need of envelope improvements, mechanical improvements, all kinds of improvements. So you might be asking, why is this not being built yet? Because it's fully designed. That's the real reason. The owner is trying to improve these existing buildings before we do any energy improvements. As a lot of people in this room know, if you could put a GEO system in a really poorly performing building, and the size of that bore field is going to really grow if you're truly going to meet those loads with just the geothermal system. So yeah, we're hoping this one goes to construction. We think it will, but it's going to take a lot of improvements to those existing buildings. There will be, I guess I could go to the next slide. No one likes to look at engineering drawings, so I'm sorry to put this up here. It's hard to see, but similar to the Haverstraw project, there's one large loop. It's in a boldish black line on here. I'm sorry, I wish it was a little darker. I highlighted the bore fields in yellow. I think across all these bore fields, there's 280 boreholes to 500 feet. And then on the right side of the screen, we're planning for a sewage heat exchange shark system as well, all to be connected by an ambient temperature loop or an ATL. Yeah, we are excited about this one. We actually just got a call from the client literally yesterday to get things back on track. So if you are joining us for NY-GEO Brooklyn in October, I hope that we have some more good news on this project. And then moving on, the last project I'll discuss today is a popular one. This one is both in construction and completed. It has multiple phases to it. But yeah, Princeton University in Princeton, New Jersey. Completely new energy facility providing 7,000 tons of cooling and about 114,000 MBH of heating capacity. Very large system, and that's solely from the GEO portion of this project. We replaced a 150-year-old steam piping system. It's the first change Princeton has had since 1746 to its energy system. So it's very well received by Princeton, the community, the students, faculty, everybody. And they're on track to eliminate all their on-site combustion by 2046. And this is a picture of what they're calling the Tiger energy plant. It's a brand new energy plant. Tiger stands for thermally integrated. I did write it down here just in case. Thermally integrated GEO exchange resource building, I believe. And it just doesn't look like any plant you've ever seen before. It almost looks like a high-end Hamptons home. So this is just really not much to follow on that piping schematic, but just to add a little more color to the project. We have about 1,000 boreholes that have been installed that are all tied back to this Tiger plant. Currently has 1,000 boreholes installed, and they plan on doubling that in the next 10 years. It also has two very large, 2.25 million gallons each, thermal energy storage tanks, test tanks, for peak times. They have a hot and a cold tank. And there is an existing open loop system, very small, but it is on site and contributes to their thermal energy network that feeds the Tiger plant. And there's also air source heat pumps that help to supplement the system and give it a little more efficiency during those ideal conditions. Let's see. And this is, I mean, another engineering drawing not many people want to look at, but this is a one-line diagram on the right showing the layout of the plant. It says future phase on the right side, but Princeton has already indicated they want to add another heat pump to this Tiger plant, which is great news. I guess going back to the picture of the Tiger plant itself, it's been designed with panels that are removable. Both the glass and the opaque panels are removable, so it's, I wouldn't call it easy, but easier than previous iterations of their power plant to perform maintenance and add ground source heat pumps to their existing array of heat pumps. So we're looking forward to working more on that, and I hope to report back on this at NY-GEO in Brooklyn in October. And I think that's it for me. So yeah, Tim. Thank you.
There we go. Good afternoon, everyone. Thank you, Donovan and Sue and NY-GEO. As the last speaker on the last panel of the day, I kept my slides down to like 48 slides, so you just bear with me. I'm kidding, I just have one. My name's Tim Banach. I'm Vice President of Development with Endurant Energy. We're a developer based in New York City. We've been involved in a number of 4614 studies, as have my colleagues here on the stage. And I've worked in the geo space probably for the last 3 to 4 years. Prior to that, I was doing a little bit of geo, but have done a lot of work thinking about and developing sort of privately owned sustainable infrastructure for new mixed-use master developments throughout the country, some in the West Coast and some on the East Coast as well. So I've done a lot of work around this. I've thought about this a lot. Yes, geo I focus on most recently, but we've also done some battery storage, some PV, some microgrids, recycled water. So I've thought about kind of various sustainable utilities for these types of applications. And while I do want to talk about financing, I kind of also want to talk more broadly about the advantages that municipalities have in helping to support and develop these thermal energy networks. And so I'm going to talk through about 6 different topics here, just generically. I won't speak to any specific project that we've worked on. But I do believe that municipalities really have a lot of levers to pull and can really drive the development of these projects. And I don't know today if it's quite clear what the model is going to be for ownership for thermal energy networks, whether it's private is the way to go, or utility owned, or some sort of combination, or municipality owned, for example. So I'll walk you through these different concepts here. So one of the advantages that municipalities have is they have a lot of open space, right? And so, this is going to benefit thermal energy networks because we have spaces to locate ground heat exchangers. I'm talking about parks and municipal parking lots, school fields, pedestrian walkways, even marginal areas that the municipality may own that may be adjacent to sort of roadways, and even kind of existing infrastructure like sewer heat exchange applications. And so when you think about sort of thermal energy networks in a sort of downtown or suburban core area, to locate those geo exchange assets, you need space, and municipalities have that. They also, oftentimes are the owners of some dense, buildings in a downtown core, can serve as an anchor tenant, right? That initial tenant to help kind of spur the business case for the project. And municipalities, forward-thinking ones have often done a lot of master planning, right? And control things like building codes and zoning regulations, right? And so can support the characteristics of a sort of a cluster that lend itself to an efficient thermal energy network. Okay, so open space is really critical, and municipalities control and own those. The next two are somewhat related. So utility corridors and rights-of-way. You know, when we talk about a thermal energy network connecting a bunch of buildings, it's likely that unless you're a college or a school campus, you're going to need to put that pipe in the right-of-way, cross a public road, right? And for private developers, sort of triggering, you know, or impeding or impinging on utility franchise rights is like a big no-no. We don't want to touch that at all. If we wanted to be utilities, we would be utilities, and we don't. And so, you know, that's a challenge that private developers and private thermal energy network owners need to overcome, right? But municipalities actually, you know, control a lot of times those public spaces, those public roads, and they're the entities that are granting permits and easements to put that infrastructure in the public right-of-way, right? And related to that, a lot of municipalities, you know, control the franchise agreements for traditional utilities, like electric, you know, municipal electric utilities are quite common. Certainly water, right? Municipal water utilities, like they, you know, approve of these franchise agreements today. And so if a thermal energy network is to be thought of like a utility, and I would argue it looks a lot like a utility, then you're going to need that municipal engagement in order to, you know, grant the franchise arrangement, whatever it looks like. A private developer isn't going to be able to overcome that on their own. And then the kind of last three items speak more to the financing and the ownership and the business model piece. So in terms of ownership and operations, municipalities actually have a lot of experience with this currently. You know, municipalities own water districts and operate them. They own wastewater sewer districts and operate those, right? Sometimes electricity. And so, again, I would argue that thermal energy networks look a lot like a utility, and municipalities have experience operating utilities for the benefit of the public. And so maybe a municipality doesn't want to take on a thermal energy network, and that's fine. But they are very well informed about what it means to operate a utility for the benefit of the folks that live in that community, right? So, and maybe they do. Maybe this is something that they want to take on. And like I said, you know, they're doing this today with utilities that look a lot like a thermal energy network, particularly like an ambient loop, a single pipe with water running through the street. This is not drawn to scale. But you can see, like, right, this looks a lot like a pipe in the ground with water running through it, connected to a bunch of buildings in a downtown core with metering and with bills going to customers. Right? So it looks like a number of other municipally owned and operated utilities. And then in terms of financing, right, even most recently, maybe with changes to the IRA, we've seen a lot of advantages and levers that utilities can take advantage of. You know, a lot of infrastructure, large infrastructure, very capital intensive, very long lifespan, kind of, you know, a lot of value proposition for folks that use it, but, you know, initially very capital intensive. Well, there's forms of financing that are set up to pay for infrastructure. Bonds, for example. You know, municipalities have the ability to issue bonds and can pay for that infrastructure. You know, similarly, like a tax incremental financing or a TIF financing, which is like a bond, but, you know, specific to a certain area. These are things that municipalities can actually enact, and that can, you know, help provide some capital for large infrastructure projects, like a thermal energy network. If you were in the room this morning and hear Jacob Goldman sort of screaming and yelling about IRA changes and ITC, it was pretty exciting. I'm not going to do that. He did that already. But there are some significant changes that make it a lot easier for nonprofits, like a municipal entity, to monetize the value of the ITC, right? Prior to this, if you were a non-tax-paying entity, you'd have to enter into a tax equity partnership with a tax-paying entity, and the structure can be quite complex. There can be a lot of just transaction costs, right? So your projects need to be kind of large capital dollar projects even to overcome those transaction costs. It means that the nonprofit and the tax-paying entity, the tax equity partner, are essentially like forced, right? They're married for a certain period of time, 5 years roughly, in order to avoid recapture. And so it's very complex, and yes, we've figured out ways to get around it. But due to changes under the IRA with direct pay and transferability, it's a lot easier for nonprofits to monetize tax equity without the complexity and the cost of a tax equity partnership. And Jacob mentioned that they're expecting, hopefully, this spring and the summer to be handing out big checks on the back of the direct pay. So that's pretty exciting. And ultimately, whether the municipality is putting forth the capital through a bond issuance, through TIF financing, is monetizing tax credits, right? There's also this partnership, right, opportunity between the public sector and the private sector. These like public-private partnerships or P3s. Whereby a municipality can partner with a private entity who can put forth the capital or contribute some capital, and the municipality gets sort of the infrastructure that they're looking for, and on the back end, the municipality may contribute sort of operating costs or maintenance costs or things like that. And so through sort of these partnerships, right, you get the best maybe of both worlds, right? You get the municipality that can help shepherd these projects through the permitting and the easements and the utility franchise rights and all the other challenges that private entities would have. And at the same time, you have access to private capital and sort of experts in the field who can help develop and design these projects. And finally, I think it's not lost that municipalities at their very core, right, are set up to provide public good, right, to provide services for the communities in which they operate. And they do this day in and day out through public education, through public safety, through maintaining public spaces, parks, roads, other civic activities, through environmental protection, right? And so, I would argue that if we as New Yorkers, Americans, your cities, if we're serious about building electrification, carbon reduction, right, getting rid of fossil fuels, and adopting new infrastructure that will last the next 100 years, right? A lot of the infrastructure we have is from 100 years ago. Municipalities have a lot to offer in terms of levers, in terms of advantages, tools in the toolbox, right, that can help realize these thermal energy networks. So I'm not advocating that public or private or municipally owned is the way to go. I think there's going to be a lot of models we're going to see in the coming years, I hope, and to get projects in the ground. But a partnership with the municipality for a district-scale thermal energy network is a necessity, regardless of which of these kind of values the municipality can offer to a project, maybe all of them, maybe one of them. There needs to be engagement with the municipality. And I'll just kind of maybe reflect a little bit on some discussion from the last panel, which is, it's really key to engage with the community and ensure that they want these assets, that they understand the value that these assets can bring, right, and are educated, and it can have discourse about what it should look like and who should pay for it, right, and kind of shape these public assets. And I think municipalities are an obvious forum for that discussion, right, and that's maybe where these things should be taking place. So at the very least, you need to be having these discussions with our partners in the municipalities, in public government, to ensure that they're educated, that stakeholders across the community have the ability to weigh in, and so that everyone can be on board hopefully everyone, majority of folks, right, to adopt this technology and be confident about the, the benefits that will come to fruition once this infrastructure is in the ground. These are big projects, and they take a lot of time, and they take a lot of money, and they need to be thought through carefully. But stakeholder engagement through the municipalities, leveraging these tools, I think is going to be key to seeing these succeed. So thank you.
Well, thank you, panelists. That was good. Thank you very much. Just so you know that these panelists represent a good chunk, almost I think a majority of the projects that were proposed to Pond 4614. And as you can see, it's public, private, municipalities, and the whole bit. So we'll open it up for questions if there are any questions. You direct. Got one right there.
John, I'm really curious about the rate, the thermal rate that you mentioned in town of Saranac Lake, which would be based on square footage, as contrasted with town of Woodstock or village of Woodstock, where you mentioned that you were hopeful that energy savings realized from getting off delivered fuels would be reinvested into energy efficiency. There's no market prod if there's just square footage. It doesn't matter if your square footage is efficient or inefficient, you pay the same rate. So I'm wondering if you could comment on thinking in those two cases.
Okay.
Oh, sorry, Sarah Collada with Siemens Smart Infrastructure.
Thank you, Sarah. That thermal rate, that was something that CHA developed. And to not really let the cat out of the bag, but there's another feasibility study heading in Westchester for a very large-scale geothermal project. And the entities that will be connected to this, they are very billboard-like, if you will, okay? So we have to find a way to do these very expensive projects without, I guess, killing them with cost. So the thermal rate used for this particular entity is PepsiCo, and it's because they've already doing a really good job where they are, but they want to do better. And so how do I tell them that they have to spend upwards of over $10 million to repipe the inside of their building? They want to know what the other guy is also going to be spending to be on to that U10 as well. So again, hearkening back to my earlier comment, I really think that, per my knowledge and understanding, we really haven't fleeced out that last little bit of detail, which is, who pays what, depending upon what they are, right? And so that square foot rate, I'm, let out the bag and kind of a little bit of risk, but that's what enabled us to make the PepsiCo and this other pilot project that's going to be a project happen. And it's attracting other large-scale government entities who want to be a part of something like this. As for the town of Woodstock, it's really difficult for us. Geothermal is expensive, and I really appreciate what you said earlier. Sorry, Dan. In the sense that I remember, years ago, people want geo in their house, and I had to explain to them for every dollar of geo could be spent $1 towards your insulation. I can give you the world's largest geothermal heat pump system in the world. It's just not going to be good, right? If your house leaks. So, it's a very fine line that I'm dancing when I'm trying to explain to this. Town of Woodstock is located in somewhat of a depressed economy area. To get there, once you get there, it's beautiful and nice, but on your way there, it's not really a pretty picture. So, how do I explain to the person who can afford geo, that they're going to get this whether they like it or not? And oh, by the way, now you have to start spending money back on your house to button it up. This is why we work with the stakeholders in the town of Woodstock. We really make it clear so that they're comfortable with the decisions that we're making. We're saying at some point we need to find the balance so that the district can still support new clients, but you need to you need to cash in on those savings, and you need to do the right thing by putting it back into your building. Because, you know, idealistically, if the municipality is now the utility and you now have a UTIN, we're all in this together. So we really don't want anyone to be a glutton and, you know, and to take away that energy, okay? So that's, I hope I try to explain your answer. You know, I'm still dancing around with the terminology, but that's one of the tools and instruments that we use, the thermal rate per square foot for Westchester County.
Yeah, thanks, John. And I'll just add, one of the things that we're doing and trying to explore through program in the new program, actually we're focusing on market development, is looking at different business models. So it's not a one, you know, size fits all. There may be different types of models for different areas or situations or and that sort of thing. So, and one may rise to be the best model, but PON 4614 was a pilot program. So we're just coming out of a pilot program to now market development. So we're still, you know, going through the stages. This one right behind you there.
Thank you to the panelists. It was incredibly interesting, and it's really, really important if we're going to have a non-utility market for distributed geothermal and thermal energy networks. A couple of things I've been thinking about. I live in Dougherty. I know that my neighbors there are not so much concerned about the climate and the environment. What they really do care about is money, saving money, and health and comfort. And I think we can go a very long way emphasizing those as elements both of thermal energy or ground source geothermal of any kind, as well as efficiency in the home. And then the second thing that goes with that, and I haven't really thoroughly teased it out, but I think the rooftop solar model can possibly help address the issue of how people use and overuse thermal energy if they think that it is unlimited. And that is, there's a tendency for people in this business to think about a thermal energy resource just like you would have gas that is distributed to an end customer who uses it up. And I think we need to really remember that these are networks, they are loops, and that every consumer is also a producer. And that, therefore, if they use less of this, if they don't cool as intensively, then they can also become a sink or they can distribute heat later. That they're part of a business, basically. And people with solar on their rooftop before VEDR especially really got that. So, no question, just gabbing.
No, that's a great point. So we're going to have two things: a consumer and a prosumer, and the same person can be both. And this goes back to what some of the panelists said about engagement with the community. We need to educate them and inform them on the benefits of this and how this will work great for them as a homeowner and the community at large. And yes, the health benefits, we want to push that. It's harder because, you know, it's hard to tell someone that you'll help mitigate upper respiratory issues because other things can cause that. So we don't want to say install a heat pump and you don't want to get asthma. We don't want to go down that path. But we know there's a health benefit because there's no carbon monoxide on site. Any other questions? Oh, right behind you, right in front of you. Then we'll go in the back after that.
Okay. Hi, my name is Nkiru. I'm from the city of Albany, and thank you for holding this panel because it's very pertinent to the work we're looking to do at the city of Albany. So I've been thinking about this question of municipal-owned thermal energy networks now for the last 2 months. So I'd definitely welcome to connect with those on the panel and already have in some capacity. So I have two questions. One is about the barriers to, so we talk about geothermal energy and that, but wastewater, thermal energy storage, sewer, heat, energy exchange, and all that, you know, that municipal water districts kind of take care of it. What are some of the barriers that you've seen to accessing that? And the second question is, are there any thoughts about the purchasing of the heat pumps maybe in a bulk manner, what can a municipality do in terms of getting heat pumps to the customers? I know that there is talk of like it's best for the utility to own the heat pump because they can deal better with the maintenance, but are there any merits to like allowing customers to own their own heat pumps? So those are kind of two very separate parts of the equation, but I welcome your thoughts on that. Thank you.
Any thoughts on it? Go ahead.
Thank you for those questions. In regards to your second question, you know, the heat pump, who makes it, who should own it, who should maintain it? As an engineer who's done a lot of time working with contractors and in the field, you know, I feel it's my obligation for all of my designs, right? These are installation manuals. These are manuals on how to build something. But at the end of the day, I need to know that what's being installed is going to be maintained and serviced. And so again, you know, much like there is no one answer fits all, you know, we have to look to, you know, in regards to Town of Woodstock, I'm thinking about who's going to do this installation, who's going to be the repairman, okay? Where are they going to get their equipment from? We as engineers, we think of these things, okay? If there's a project in Sarah, you know, if there's a project, for example, we've got this one NYSERDA feasibility study out in Clay, Toca Village, right next to a chip foundry. Self-performing developer, he's going to build the neighborhood for that chip foundry workers, okay? Water Furnace is going to make all those units. They're going to put a stamp on it, and they're going to say, this is the Toco Village Water Furnace units, much like we have down in NY-GEO, you know, NY-GEO buildings in New York City. There are very special pieces of equipment manufactured for NY-GEO, maintained by NY-GEO, and the manufacturer doesn't talk to anybody else about what's going on there. So there will be a balance point. We often want to find a very good, reliable, you know, piece of equipment, but the thing that we're not talking about is the system is only going to work as good as the people who are maintaining them and fixing them. So back to the education, okay? I've walked projects and I've seen 60-year-old unit ventilators, and people are making comments on, you know, how those things need to go because, you know, they're old and original, and I say, no, they need to go when the repairman who's been fixing that for 60 years gets ready to retire. So we choose our heat pumps, we look to the environment, we look to the immediate area, we look to see who can possibly support those projects, and then we make our decisions from that, based on that. Okay?
Okay. We have a question back there. Khalid?
Where am I going? Right here. Oh, hi. I thought you were pointing. Hi, my name's Jason Masters. I'm the Director of Energy for Borough Happold, US. My question is, well, actually, let me set the stage first. So the biggest question of whether these U10s are going to be profitable enough are going to come down to understanding the actual economics. The issue is that we don't understand the economics right now. We're looking to people who are actually installing these systems across the US. So we are the consultant for heat right now and for Building Decarb Coalition. And what I'd like to ask the panel is, would you be willing to enter into either a confidentiality or some sort of anonymous survey so that we can start capturing these prices so that heat and or Building Decarb Coalition can start building a model so that we can start pushing these, this information out to the community and start parameterizing these costs to then start driving them down to something that's more efficient.
So I'm going to interject there a little bit, because I'm not going to ask the panel publicly to say they're going to engage in a confidentiality agreement. Maybe after the panel, you can approach them and talk to them individually, but I don't want to put competing engineering firms on the spot like that.
Can you answer the question about the limitations to wastewater?
Sure.
That was
And then I'll have one question for the group, but yeah, after you dance, and then I'll ask one final question.
Thank you for reminding me about that first part of the question. So the biggest challenges to these alternative ways of finding a source or a sink, like surface water, is that, again, there's just the fear factor. Like, you know, how do I explain to somebody that I'm going to tap their wastewater treatment plant twice for a source of heat, on the human waste going in and on the effluent going out? You know, once they comfortably understand it, or they have, like, I'm sorry, I'm gonna show a little personality here, but you know, I tell my kids the noodle dream, you know, from Kung Fu Panda, like once you see the light bulb go off and they've had the noodle dream, then it makes sense, they get it. So it really is a challenge of like, how patient can I be? How long can I stand still and just take all the tire kicking on, you know, well, what about this? What happens if this happens? And, you know, you just have to spend the time to educate, to get them to see the light. But also remember that, you know, geothermal is not a magic cube. It doesn't fix everything. It has its limitations. But the cool thing is that we can be very strategic in identifying low-hanging fruit and opportunities to scavenge that energy. And it's through the use of the heat pump that we can do that. So, you know, the challenges has just really been like, how creative can you be, and you know, try not to get in trouble with your imagination.
Well, I think we're at time, so I won't ask the question. Thank you so much for coming to the New York GEO Conference 2024. Hopefully you found it informative. We'll see you in Brooklyn in October.